Welcome, everybody. We're going to start off our year with reviewing sets and their operations. Today, we're going to talk about some basic definitions. So, following along on your note sheet, we start out with a set. A set is a collection of objects. Now, we're making sure that we're writing set with these braces. I call them the squiggly doohickeys. But 1, 2, 3, and 4 is a set. The objects are 1, 2, 3, and 4. The elements or members are those objects that belong to a set. So again, above 1, 2, 3, and 4 are elements or members of that set. A way that we can write this to say that 4 is an element of that set is with this funny looking sideways E thing. That means element. So this says 4 is an element of the set 1, 2, 3, 4. A finite set, same as a finite anything else, means that it ends. It has an ending. There's a limited number of elements in there. And you'll notice the difference between a finite and an infinite set, where infinite is unending because of these dots in here. So when you have something that ends, it's going to be like 1, 2, 3, 4. Or 0, 2, 4, 6. Yes, we have dots here, but that doesn't mean that it's finite because our very last thing written is 14. All those dots mean in this case is the pattern continues and it stops at 14. We just didn't want to write all of the numbers down. Maybe we were too lazy or there were too many or whatever. Versus in the infinite set, 1, 3, 5, then ... says this pattern continues indefinitely until we get tired of writing numbers. Same thing with this next one, -2, 2, 6, 10. It's a pattern of adding 4, and the ... says this pattern is going to continue forever and ever and ever. A few other things we want to make sure that we note, and that is the capital letter N. So N here stands for the set of natural numbers or counting numbers. Counting numbers are 1, 2, 3, 4, 5, and so on. We also want to talk about set builder notation. Set builder notation looks like this. Okay, we have our braces on either side. And then this is X such that X. That's what this circled part means. X such that X is a natural number between 2 and 7. And the answer to that would be 3, 4, 5, and 6. So the set of 3, 4, 5, and 6. Go ahead and pause this if you need to write anything down that you missed, and then head over to example 1. Classify each set as finite or infinite. That's the first thing we're going to do. So 7, 8, 9, 14. This set is going to be finite because we don't have dots at the end. We have a 14 at the end. Then determine if 10 is an element. So it looks like the pattern is starting at 7 and ending at 14. We're going up by ones. So would 10 be an element of the set? Oops, I'm not very good at writing those braces. And the answer is yes. And so we write that using this part right here. 10 is an element. That funny sideways E means element. The next one, letter B, we have 1, 1/4, 1/16, 1/64, and then ... So because there's nothing here at the very end, this is an infinite set. And then looks like we're multiplying by a 4th every single time. So is the whole number 10 going to be ever in this set? No, it would not. And so to write that, we write it the same way as we did when it is, but we put a line through it, just like, when we're doing no or empty set or something like that. It's got a line through it saying, nope, 10 is not going to be an element of that set. All right, letter C. Remember, this x line x is x such that x is a fraction between 1 and 2. Well, I could start writing some of those. 1/10 would be a fraction, 1/4 would be a fraction, 2/3 would be a fraction. But really, there's an immeasurable amount of fractions that we could potentially write between 1 and 2. So this is going to be an infinite set. And because we're between the values of 1 and 2, 10 is not going to be an element of that. And I'm just going to shorthand it for right now for space sake. And then last but not least, we have this right here, x such that x is a natural number between 9 and 11. Now, they didn't say between and including. They said between. So the only natural number, remember, natural numbers are counting numbers, that are between 9 and 11 is 10. So 10 is the answer to that set, which means 10 is an element of that set. Continuing with these, so x such that x is a natural number less than 5. So again, natural numbers are counting numbers, 1, 2, 3, and 4. Those are going to be the natural numbers that are less than 5. Remember, it did not say less than and equal to. If it said less than or equal to, then we would keep 5 in there. And so that would be all the elements of that set. We are again x such that x is a natural number greater than 7 and less than 14. Remember, it didn't say greater than or equal to, less than or equal to. So 7 and 14 are not part of our answer. So greater than 7 is going to be 8, 9, 10, 11, 12, 13. And then we stop there because the next number would be 14. Special sets. So we have the universal set, which contains all elements of a problem. It is represented by a capital letter U. So whatever problem we're looking at, we wouldn't start breaking people off into groups. It's like saying, I have the senior class, and then I'm going to break the senior class up into people who love math and people who love English. So the people who would love math and the people who love English would be the smaller sets, but the universal set would be seniors. The null set or empty set is a set that contains no elements. You can either draw this symbol right here. I only put those parentheses there so it would kind of stand out, or this symbol here. You cannot combine the two. You cannot do this. All right. Otherwise, what would happen is if you did write this, then that has an answer, and that answer is the empty set. It's not nothing. These mean there's nothing. This down here means the answer is the empty set. Subsets. So like we were just talking about, we said the universal set would be seniors. And so if we made a set M of students out of the senior class who enjoyed math, and the set E of students who enjoyed English, then math and English would be the subsets because they are subsets of the universal. The symbol for a subset is the sideways U with a line underneath it. We have set A is 2, 5, and 9, and set B is 2, 3, 5, 6, 9, 10. Then A is a subset of B because all of these are found in here. B is not a subset of A because A does not have 3, 6, or 10. Last example for this set, we have the universal set. So remember, these are all the numbers that we're focusing on. Going back to, this is the senior class. And then we broke that class down into different groups. So we're saying, is this true or false? I'm going to change colors here. We have, is D a subset of B? So here's D. D has numbers 1 and 9. Are 1 and 9 found in B? Yes. So this is true. Next, is B a subset of D? Remember, that means that D would have to have every single number that B has. So we need 1, 3, 7, and 9. Well, D has 1 and 9, but not 3 and 7. So I draw a line through that because that is false. D does not have all the elements of B. Is set C a subset of A? Won't work very well. Let's try this. All right. So C has 3, 9, and 11. A has 3, 9, and 11. So are all of C found somewhere in A? Yes, that is true. Is the universal set equal to set A? Do they have all the exact same stuff? So we have 1, 3, 5, 7, 9, 11. Nope, because the universal set has a 13, but A does not. So that's going to cross the line. They are not equal, and that is false. That's where we're going to stop for today. If you have any questions, please make sure that you reach out. Have a great night.